So this morning I was working on some problems for the MIT 2020 integration bee, and I checked the website for a solution, and look what I found. So just posted this morning. Well, today's the 23rd, I think, so who knows when you're watching this video, but yep, they have the 2025 integration bee posted, and I did like 8 problems. So the first few are pretty easy, but let's give it a try. Okay, like I said, MIT likes to start off pretty easy, and so this is problem 1 from 2025. For this, at first I was messing around with the U substitution, and you can do it that way, but I think it's kind of nice to just factor it. For the numerator, if I factor out square root of x, then this first piece is going to be square root of x plus 1. But then we can just put this back into the integral, and we have square root of x. Let's reorder it to make it really obvious. And we'll try to write the plus sign, right? So that there's someone in the comments that doesn't like my plus sign, so I'll try to do better. So here what we get is clearly cancellation. And so all we're integrating here is going to be x to the 1/2 dx. So let's just go ahead and use power rule on it. X to the 3/2, 2/3 in front, add a plus c, and that's it. Wow, I think I better do one more, but that's not, you guys aren't going to be happy if I give you a 30-second video. So let's do number 2 and see what that one's all about. Shoot, not really any harder. Now, we do have this weird thing in the exponent where we've got e to the x plus 1. Well, with exponent properties, I can write this as 2 separate terms. You can think of this as like e to the 1 here. But then e to the 1 is just a constant, so I could bring that out front of the integral. And then for this, you could do it in your head, but let's do the u substitution for the whole denominator. So we'll say u equals e to the x plus 1 du is equal to e to the x dx. So substituting this, we got e, du's the whole numerator, and then we're just left with u in the denominator. So integrating it, we get e natural log absolute value of u. But our u value, this is always positive. The exponential can't ever be negative. So what we've got for our final solution here is just e natural log e to the x plus 1, add a plus c, and that's it. Okay, one more. I'm just doing 3, and we'll call it good. So moving on to number 3. Okay, this one's a little more interesting. What we've got here, we've got the cube root of 3 sine x minus sine 3x. This looks a lot like our triple angle formula, maybe just rearranged. But let's say that we don't remember that, and I don't actually remember it exactly anyway, but let's kind of derive it from this. If I just take sine 3x, but I'm going to write it as, we'll write it like this, 2x plus x, same thing as sine 3x. Then using the different angle formula on this, it's going to be sine 2x cosine x plus sine x cos 2x. And then you can simplify this a whole bunch of different ways, but what I want to do is I want to get it all in terms of sines and all with a single angle. So first, for sine 2x, I can write that as 2 sine x cos x, multiply it times this one, and we've got cosine squared x. And then here, we'll get this, we'll use the double angle formula for cosine, but I want the one, because I'm trying to get it in terms of sines, so I'm going to use this version of it and write it as 1 minus 2 sine squared x. But then I can distribute this part in here. For cosine squared x, I can write that as 1 minus sine squared x, getting everything to sines. And then let's just distribute everything out and see what we have. So multiplying in 2 sine x here, we're going to have 2 sine x minus 2. This becomes sine cubed x. And distributing this part out, we get sine x minus 2 sine cubed x. Simplifying it, what's going to happen? We get the like term here, so we're going to have 3 sine x minus 4 sine cubed x. But now let's take this value here and plug it back into our integral with a minus sign in front. So what's going to happen is now we have all inside the cube root. We still have this 3. I haven't touched this yet, so we have 3 sine x. Distributing the minus sign here, we get minus 3 sine x. Minus times minus is plus 4 sine cubed x. But now 3 sine x minus 3 sine x, that's just 0. So we're just dealing with 4 sine cubed x. We can simplify this more because breaking this up, we can have the cube root of 4. So I'll bring out in front cube root of 4, integral of cube root sine cubed x. But the cube root of sine cubed, that's just going to be sine x. So what we'll do is we'll just go ahead and integrate it. Integrating sine, that's just going to be minus cosine x. And so cleaning it up for my final solution, we just get minus cubed root of 4 cosine x plus c, and that's it. And I just noticed something. This is problem 3, and they've got 3 here, here, and here. So that's not a coincidence. I think they really wanted to, yeah, that's definitely on purpose. Okay, there you go. Problems 1, 2, and 3. Thanks everyone for watching. Have a good day.